Hey guys, what's up? Sekhar here. Today in this video I am going to give you a small introduction to stack and queue data structures. Then we'll solve a problem in stack and queue. By the end of this video you will be having a basic understanding of these two data structures, which are very widely used to solve competitive programming questions. So let's first discuss about a stack, how a stack works. So basically, as you can see, I have created a sample stack. I have already inserted 3 elements into a stack, and there is a pointer pointing to the topmost element on a stack, which is pointing to 5. Now in a stack, the element deleted from set is most recently inserted. So basically, if you think the most recently inserted element is 5 here, so if you on a stack there are two types of operations which can be performed. First one is for insert, it's called push, and for removing an element from a stack, it's called pop. So let's say if I want to push a new element to a stack, so I will perform the push operation and I want to insert 9 into the stack. So the new stack would look something like this: 1 3 5 9, and the pointer will come here, top pointer. Now second operation is pop. So if you want to perform pop, so in first one you need to pass a parameter which will be the element you want to insert into the stack, but for second operation delete, you then don't need to pass any parameter, and pop operation removes the topmost element from a stack, which is the most recently inserted element. So in our case it's 9. So if you perform a pop operation on this stack, so 9 will get removed from the stack, and new stack would look something like this: 1 3 5, and top pointer will point to 5 now. So that's how a stack works. You can think of a stack like a stack of plates in your cafeteria. So plates, first plate which will be inserted will be this one, then second, then third. But if you remove the first one, the first plate that you remove would be the last one inserted. Now let's have a quick introduction of queue. What is a queue and how it works. So in a queue, the element deleted is always the one that has been in the set for the longest time. The queue implements a first in first out policy. So the element which got inserted first will get removed first. Now in case of queue, we call the insert operation as in queue and delete operation as dequeue. So let's say I have a sample queue where I already have 3 elements in queue: 1 2 3. In queue there are 2 different pointers which is required. So first one is head of the queue and second one is tail of the queue. Now when you insert an element in queue, that operation is basically called in queue. You are inserting an element. In queue operation requires a single parameter, which would be the value you want to insert into the queue. Let's say I want to insert 9. So in that case, my existing queue is 1 2 3 with head pointing to 1 and tail pointing to 1 and tail pointing to 3. Now if I insert element 9 into this queue, then the new queue which I will get would look something like this: 1 2 3 and 9. So the new element got inserted at the end of the queue, and the tail pointer is moved from 3 to 9. So that's in queue operation. Then the second operation is delete. So for delete, it's called dequeue, and it doesn't require any parameter as it will remove a existing element from the queue. So a dequeue operation from queue removes the element which got inserted first into the queue. So here in our case, the queue has 3 elements: 1 2 3, and head is pointing to 1 and tail is pointing to 3. Now if I perform a dequeue operation, the first element which got inserted is 1, so 1 will get removed and head pointer will move to 2. So That is the basic introduction to queue. Now as we are good with the basics of stack and queue, let's go ahead and discuss a problem on stack and queue. So the problem statement is we want to implement a queue using two stacks. So how to achieve that? So basically the problem boils down to something that we have to implement in queue and dequeue operations using two stacks. So let's say I have two stacks, S1 and second one is S2. I'm assuming that S1 will work as tail of the queue, where S2 will work as head of the queue. So as we discussed previously, whenever we want to remove one element from a queue, it always comes from head, and when we want to insert a new element into queue, so that time we have to insert from tail side. So let's say I want to insert 3 into the queue. So I will as the S1 is working as tail of the queue, so I will do a push operation on this stack S1. So 3 gets pushed here. So 3 is the first element. Then let's say again I want to insert a second element, which is 9. So in queue operation then again translates to S1 dot push, which is push the second element to S1 stack. Now as you see here, again second element got pushed, which is 9, but stack 2 is still empty, which is working as head of the queue. Now let's go to the second scenario where I want to remove one element from the queue. So in this case I need something to be there on stack 2, because stack 2 is working as head of the queue. So first thing which we need to check is for S2 dot size. If the size of this stack is 0, in that case we need to get some elements here in head part so that we can remove it. So when S2 dot size is 0, that time we need to pop elements from S1 and put it on the second stack S2. So if you will notice here, the last element on stack 1 becomes the first element inserted in stack 2. So here the actual operation translates into dequeue operation, translates into S1 dot pop and then S2 dot push, which means pop 9 from stack 1 and push it into stack 2. So then 9 becomes the first element. Now the second operation is pop the until all the elements are not exhausted, keep popping and push all the elements to stack 2. So second element is 3, so it gets popped from stack 1 and pushed into stack 2. Now the third operation, so if you notice here, we inserted 3 at first, so 3 becomes the last element on a stack 2, which means this works as the head of queue, head. Now if I want to dequeue one element, so easily I can remove 3 from here, so that operation is performed into as S2 dot pop, so 3 gets removed. Now let's discuss a third scenario where I want again to insert a new element 4. So in this case I want 4 to be inserted into queue. So S1, as S1 is working as tail, so I will insert that element into S1, and still I have one element left on S2, 9, because 3 is already popped. So if the second operation which I want to perform is dequeue, in that case if I will check the size of a stack 2, so it's still 1. There is already one element here, so we cannot pop elements from a stack 1 and push it here. That would be a wrong operation. Instead of that, we need to pop the existing element from here. So I will check S2 dot size. If size is greater than 0, that means we can directly pop an element from stack 2. So that's what is happening here. If I will run the S2 dot pop, so 9 will come out of this stack and S2 will become empty. So that's how the problem implementing queue using two stacks can be solved. Already discussed how to implement a queue using two stacks. Let's go ahead and implement it to see how it works in actual code. So here, if you see, I have input like this. 10 represents the number of queries which is going to be there, and this is a new line character which says the each entry is in a new line. I'm using JavaScript as the language. You are free to use any language. Here in query there is a format. So if first character is 1, that means we want to enqueue one element. If it's 2, that means we want to dequeue a element, and if it's 3, that means we want to print the first element in the current queue. So with that, let's see how it works. Our main method, I have written a main method. So here input is this, and the actual input which I have given is a string. So I need to get the actual query out of this string. So I'm taking it as an input array by splitting. So this is the JavaScript part. Now the actual concept comes here. So I'm taking one stack. So this is the first stack which will work as the tail of the queue, and the second stack 2, will work as head of the queue. Now there are 3 operations which I already discussed. First one is, if the query is 1, that means I want to enqueue element. If query is 2, that means I want to dequeue element, and if it's 3, in that case I want to print element. So accordingly I have written 3 different methods for doing this. So first method is enqueue. So if you see, basically enqueue is a very simple method. Here I am passing the stack which works as the tail of the queue, and then second parameter is a number, which is the number we want to insert into the queue, and we are directly pushing it to stack 1. That means we are inserting elements in stack 1. Second method is dequeue. In dequeue we need stack 1 as well as stack 2 to remove elements. So let's go ahead and see the implementation of dequeue. It takes 2 parameters, stack 1 which is tail of the queue, and stack 2 which is head of the queue. When stack 2 is empty, all elements from stack 1 can be pushed on stack 2. The last element on stack 2 represents the first element of queue. So first check is stack 2 dot length. If it's 0, that means we need to pop the elements from stack 1 and push them onto stack 2. So if stack 1 dot length is greater than 0, that means there is an element on stack 1. In that case, I will pop the element from stack 1 and push it to stack 2 until the stack 1 is not empty. Empty means stack 1 dot length would be 0. Now finally the dequeue operation returns the popped element, which is the dequeued element for queue. So final element is removed from stack 2. Now let's see the third one. So third method is to print the first element on queue. So it takes 2 parameters, stack 1 and stack 2, and then it does a dequeue operation by passing a stack 1 and a stack 2. So dequeue operation, as we have already seen, returns the removed element. So ELE element is representing that removed element. I'm logging that element and then again pushing back to a stack 2, because in print we don't want to do an actual dequeue operation. That's why putting back on a stack 2 again. So that's how the whole concept can be implemented in JavaScript. Now let's go ahead and run it quickly. So if you see here, I have my method, my JavaScript file queue with to stack. This is the actual file which we have seen. Now I'm using Node.js for running this code. It depends like in which language you want to write. You can write in any language, but concept remains the same. Only difference in some languages you need to implement the actual stack, but in JavaScript we already have implemented a stack with push and pop methods, so it can be easily used to implement a queue. Now if I write here node queue with two stacks, so the output is 14 14. So let's see how the output is coming. So first entry is 10, that means I want to give 10 number of queries. Now first query is 142, that means I want to insert element into queue, that is a in queue operation. So now the queue is having 42 as its tail as well as head element, because there is only one element. Now second operation is 2, that means I want to remove element from queue, so that is a dequeue operation. Now a stack again becomes the empty stack. Third operation is in queue again, so now queue has one element which is 14. Now next action is pre, that means I want to print the existing element which is at first position head of the queue, so 14 will be printed. So that's how you are able to see 14 here first. Then again I want to insert a new element which is 28, so now the queue is 14 then 28 is at the tail and 14 is at the head of the queue. Now next operation is print again, so as 14 is already there, so it will print 14 again. So this is the second output. Then again I want to insert element into queue. Now queue would look something like 14 28 and 60, then again 78, because that is also a in queue operation. Then two dequeue operations, so that means 14 first gets removed, then 28 again gets removed. Now the queue is left with two elements 60 and 78, where 60 is head of queue and 78 is tail of the queue. So that's all about implementing a stack implementing a queue using two stacks. You can refer to the GitHub link, I will give it in the description box. Thank you.